California lawmakers and the governor are now appealing to the White House to make a disaster declaration. Authorities say they are making progress tonight and may be able to avoid a catastrophic disaster. There is desperation to find a solution to this crisis. The tank is located in a densely populated area just miles away from two Disney theme parks, Angel Stadium and Knott's Berry Farm. At least 50,000 people in Orange County have been forced to evacuate their homes and seek residence in temporary shelters. And the mayor is warning residents not to ignore those evacuation orders, calling this a very dangerous situation. ABC's Jacqueline Lee leads us off from the command center.
Tonight, progress in the desperate efforts to prevent an environmental disaster in Orange County, California. Crews able to get close enough to that unstable 7,000-gallon tank full of hazardous liquid, finding a potential crack, offering a glimmer of hope. Why would this be a good thing?
So the thing about the crack is what we're looking for. It's going to relieve pressure. We want the pressure relieved out of that tank.
He goes on to explain there could still be an explosion, just not a catastrophic one. For days, officials have feared the tank would either explode into a fireball, igniting nearby tanks, or the methyl methacrylate, a highly volatile chemical inside, would leak out. Even short-term exposure could cause skin and eye irritation and breathing problems. More than 50,000 residents remain under evacuation orders. Two residents filing a class action lawsuit yesterday against GKN Aerospace, the company in charge of the tanks. And tonight, the governor requesting President Trump issue an emergency declaration to support response operations. The EPA saying it has been monitoring air quality since Friday.
We've been involved in the modeling of different scenarios. We're being told that the tank will fail, but there are different scenarios as to what that means.
The evacuation area is a densely populated area and is not far from several major area attractions, including Disneyland, Knott's Berry Farm, and the Angel Stadium. The Angels going ahead with a game tonight against the Rangers. Officials insisting the areas outside of the evacuation zone are completely safe. Lindsay, crews will conduct another operation tonight, and if all goes well, it's possible authorities will shrink the evacuation zone. Lindsay.
So many hoping that's the case. Jacqueline, thank you.
Some kingdoms thought they'd beaten the desert. They thought they outsmarted nature itself. They built skyscrapers in the sand, cities the size of countries, farms where nothing should grow. And for a few decades, it actually worked. But then it stopped working, because these nations were never beating the desert. They were just borrowing from it. And the bill is coming due. What we're about to break down is one of the most insane gambles in modern history. A gamble that turned barren wasteland into glittering megacities. A gamble that fed millions, fueled global oil markets, and rewrote the map of the Middle East. A gamble that, on the surface, looked like a miracle. But every miracle has a price, and the nations of the Gulf are about to find out exactly how much theirs is going to cost them. Because the resource that built everything they have, it was never supposed to last, and nature is about to take all of it back. Let's start with what people see from the outside. Look at the skyline of Dubai in 2026. Burj Khalifa scraping the clouds. 8-lane highways cutting through what used to be just empty desert. Lush parks in a city where average rainfall is barely 100 millimeters a year. Indoor ski slopes in a country where summer temperatures regularly cross 45 degrees Celsius. Artificial islands shaped like palm trees, dredged out of the seabed itself. Fountains that shoot 150 meters into the air in one of the driest places on the planet. Then look across the border to Saudi Arabia. Riyadh, a megacity of over 7 million people in the middle of nowhere. Neom, a planned futuristic city the length of Belgium, rising in a desert so harsh that for most of human history, almost no one lived there. Wheat fields, dairy farms, date plantations, all stretching to the horizon. For thousands of years, the Arabian Peninsula was one of the harshest places on Earth. Bedouin tribes would survive by moving constantly from oasis to oasis, whose civilizations formed around a single well. Water was so precious that it shaped religion, war, marriage, and law. The Quran itself, revealed in this exact desert, mentions water more than 60 times. And then, in less than a single human lifetime, all of that changed. Cities exploded out of the sand. Populations multiplied. Saudi Arabia alone went from roughly 2.5 million people in 1960 to over 35 million by 2024. Glass towers replaced tents. The desert that had defeated every conqueror in history was suddenly being landscaped. To the outside world, it looked like a miracle. To the people running these countries, it looked like proof that with enough money and enough engineering, nature itself could be defeated. But there was something that they weren't telling anyone, something most of their own citizens didn't fully understand, because every drop of water keeping that miracle alive was coming from a source that was never going to refill. And once the truth got out, the entire model started looking less like progress and more like a countdown. So how exactly did they pull it off? Well, for decades, the official story was simple: desalination. You take seawater, run it through massive industrial plants, strip out all the salt, and pump fresh water into the cities. Saudi Arabia became the largest desalinated water producer on the planet. According to its own Saudi Water Authority data, published in 2026, the kingdom now produces over 11.1 million cubic meters of desalinated water every single day. That's more than any other country on Earth, and it accounts for roughly 70% of the country's drinking water. Bahrain pulls 90% or more of its drinking water from desalination. Kuwait, same thing. Qatar, almost 99%. Across the Gulf Cooperation Council, countries that include Saudi Arabia, the UAE, Kuwait, Bahrain, Oman, and Qatar, desalination plants now produce close to half of the entire world's desalinated water. The whole region is, quite literally, drinking the sea. But here's what most people miss. Desalination is the visible part of the equation. The cities, mega projects, the 7-star hotels with marble fountains, well, those are the ones that the cameras see. But what the cameras don't see is the second half of the system, the part that's been running in parallel for almost 50 years, the part hidden under the sand. Because long before the desalination boom, when these countries were first deciding to grow wheat, dairy, and forage crops in one of the driest places on the planet, they tapped into something else entirely, something far older, something that, if they were honest with their own populations, they would have admitted was never theirs to use in the first place. It was a kind of water that almost no one outside the world of hydrology had ever heard of, a type of water that doesn't refill, a type of water that, once pumped up and used, vanishes from the planet permanently, and entire civilizations have been quietly drinking from it. Hey, if you're with us so far, hit subscribe, because what we're about to reveal is the foundation underneath every glittering Gulf megacity, and once you see it, you can't unsee it. Hydrologists call it fossil water, or paleo water, or more chillingly, ghost water. It's water that fell as rain or snow tens of thousands of years ago, when the Arabian Peninsula was a very different place. A wetter, cooler region during the last ice age, when monsoons would reach deeper into the desert and rivers would run where there are now only cracked riverbeds. That water seeped into the ground, settled into massive porous rock formations hundreds of meters below the surface, and stayed there for 10,000, 20,000, in some cases more than 30,000 years. Carbon-14 dating of the water still being pumped in some Saudi farming regions has confirmed it. The water filling Saudi cattle troughs in 2025 is, in some cases, older than recorded human civilization. It was already ancient when the pyramids were built, already ancient when the wheel was invented, already ancient when the first writing systems appeared in nearby Mesopotamia. And in the modern desert above it, at less than 100 millimeters of rainfall per year, this water doesn't come back. Not in a year, not in a century, not in 1,000 years. Hydrologists are clear on this point. Once you pump it out, it's gone, permanently. The Gulf states didn't just dip into this resource, they built entire economies on top of it. Starting in the 1970s and then exploding through the 80s and 90s, Saudi Arabia poured billions of petrodollars into desert agriculture. They installed enormous center pivot irrigation systems, the round green circles you can see from space. They drilled wells hundreds of meters deep into the Arabian aquifer system, which extends beneath Saudi Arabia, Yemen, Oman, the UAE, Qatar, Kuwait, Bahrain, Iraq, and Jordan. NASA's Gray satellite mission would later confirm what scientists already expected. This is the most overstressed aquifer system on the planet. Around 60 million people depend on it, and it's being drained at a rate that cannot survive. By the mid-1980s, Saudi Arabia had become a wheat exporter. A wheat exporter in a desert country with virtually no rivers, lakes, almost no rainfall. Saudi production peaked at around 2.5 million tons a year. Most of that wheat was being grown on water that was 10,000 years old or more. They were exporting fossil water in solid form, baked into grain, and then shipped overseas. According to estimates from National Geographic, and based on a 2004 paper from the School of Oriental and African Studies in London, when intensive modern farming began, there were roughly 500 cubic kilometers of water beneath the Saudi desert, enough to fill Lake Erie. By 2008, an estimated 400 of those 500 cubic kilometers were already gone. By recent estimates, around 80% of the country's fossil water has now been pumped to the surface and used. 80%. In one human lifetime, these countries used up water that had taken the planet tens of thousands of years to store. So why didn't the alarm bells ring sooner? Because the collapse of a fossil aquifer is not loud. It's not visible. It doesn't flood your streets or wash away your roads. It happens in slow motion, hundreds of meters underground where almost no one ever looks. For years, it didn't even feel like anything was wrong. Wells still produced water, crops still grew, cities still expanded, oil money kept pouring in, and the same governments that were quietly draining the underground reserves were also pouring billions into shiny desalination plants on the coast. From the surface, the system looked unstoppable. But underneath the desert, the water table was falling. In areas like Wadi ad-Dawasir in Saudi Arabia, NASA satellites and UN reports documented water tables dropping by as much as 6 meters per year since the 1980s. 6 meters every year. In some farming regions, original wells went dry and had to be re-drilled deeper, then deeper again, and then deeper again. And every meter that disappeared was water that the planet was never going to put back. The same thing was happening across the border in Iran, where centuries-old water tunnels called qanats, ancient gravity-fed systems that had sustained life on the Iranian plateau for over 2,000 years, were being systematically abandoned. These tunnels, an engineering marvel recognized by UNESCO, drew on shallow groundwater in a way that allowed it to recharge naturally. They had kept Persian civilization alive through droughts, invasions, and empires for 2 millennia. Iran chose dams and modern wells instead, building over 600 dams and drilling so aggressively that the whole regions began to sink. Tehran province, by official admission of President Masoud Pezeshkian in November of 2025, is now subsiding by up to 30 centimeters per year. Roads are cracking, buildings are tilting, underground voids forming where ancient water used to be. The qanats in many places were filled in or simply forgotten. This is the part that should have terrified everyone. Not the spectacular waterfalls of Dubai, not the wheat fields of Riyadh, but the slow, silent disappearance of the actual water beneath their feet. But because nothing visible was happening, the projects kept getting bigger. And that is where the real trap was set. Because the system didn't keep going. It got more ambitious, more expensive, more dependent on resources that didn't exist anymore. Saudi Arabia kept building. Neom, a planned megacity longer than the entire country of Belgium, was announced in 2017 with a price tag estimated by some analysts at over $500 billion. It's being built in a region where natural fresh water is essentially zero. The flagship development, a 170-kilometer mirrored skyscraper called The Line, would house residents in a structure that, according to leaked internal documents, would consume more water and energy per capita than any city in human history. Dubai expanded its skyline into the Persian Gulf itself, building artificial islands on top of the seabed. Qatar hosted the 2022 World Cup, with stadiums cooled by air conditioning blasting at full power into open air in 40-degree Celsius heat, fueled in large part by a state-run grid that also powered the desalination plants that kept the country alive. The new Lusail city, designed for almost 200,000 residents, was built almost entirely on desalinated water in a country with effectively no rainfall. Population numbers exploded across the region. The UAE alone went from a population of under 200,000 in 1960 to more than 11 million by the mid-2020s. Most of that population is concentrated in cities that depend almost entirely on desalinated water and food imports. Take away the energy that runs the desalination plants, or take away the ships that bring in the food, and these countries face a crisis within days. And the food imports are themselves a hidden water bill. Most of the wheat, rice, and animal feed eaten across the Gulf is grown somewhere else, using somebody else's water and shipped in by sea. After Saudi Arabia killed its domestic wheat program in 2016, the kingdom started leasing huge tracts of farmland in Africa and South Asia, exporting its water dependency to other people's aquifers. The Desert Miracle was now quietly draining countries thousands of kilometers away. That's not a stable system. That's a high-wire act. And for years, it was held in the air by a single thing: cheap fossil fuel. To turn seawater into drinking water, you need enormous amounts of energy. According to research from the French Institute of International Relations and confirmed by the Atlantic Council in 2025, Saudi Arabia alone burns roughly 300,000 barrels of oil every day just to power its desalination plants. The kingdom's total electricity consumption for water desalination has tripled since 2005, now equivalent to the annual output of a major nuclear power station. Let that sink in. An entire nuclear plant's worth of electricity every year just to keep the taps running. This is the structural reality that the Gulf has been hiding behind a wall of marble and glass. The wealth comes from selling oil, the oil pays for the desalination, and the desalination keeps the cities alive. But take away any one piece and the whole tower begins to wobble. Add in the fact that fossil water under the desert is now 80% gone, and the wobble starts looking like a collapse in slow motion. Then nature decided to push back, because while the Gulf states were busy draining their underground reserves and building their coastal water factories, the climate above them was shifting. And it wasn't shifting in their favor. Air temperatures across the southern Gulf are now rising at around 0.5 degrees Celsius per decade. That is almost double the global average. Sea surface temperatures in the Persian Gulf are rising at around 0.4 degrees Celsius per decade. The Gulf is already one of the hottest seas on the planet, regularly reaching 35 degrees Celsius at the surface. Coral reefs that survived for thousands of years have bleached and died in repeated heatwave events since the late 1990s. Inland, the picture is just as dark. According to the World Weather Attribution Analysis published in November of 2025, the entire Fertile Crescent, the region the Tigris and Euphrates flow through, is in the middle of a 5-year drought made significantly worse by human-driven climate change. Iraq, the original land between the rivers, recorded its driest year since 1933 in 2025. The Tigris and Euphrates dropped by up to 27% that year alone. Iraqi water reserves fell from around 18 billion cubic meters to roughly 10 billion in just 12 months. The legendary Mesopotamian marshes, recognized as a UNESCO World Heritage Site in 2016, have shrunk to as little as 7 to 10% of the original size, according to figures cited by Iraqi President Abdul Latif Rashid in June of 2025. Buffalo carcasses now dot the cracked mud where reed beds used to stand. The water minister of Iraq announced in summer of 2025 that September wheat planting was being suspended entirely because there simply wasn't enough water. Across the border in Syria, the picture was even uglier. According to research published by World Weather Attribution in November 2025, rainfall in parts of Syria had collapsed by close to 70%. Around 3/4 of the country's rain-fed farmland was crippled. The wheat shortfall alone was estimated at 2.73 million tons. A region that had fed empires for thousands of years was, in the span of half a decade, becoming agriculturally unviable. And then came Iran. In November of 2025, Iran's President Masoud Pezeshkian gave one of the most extraordinary speeches by a head of state in modern memory. He told the country that if rain did not fall on Tehran by December, the city of around 15 million people might have to be evacuated. The 5 main reservoirs that supply Tehran had dropped to roughly 11% of capacity. The Latyan Dam, one of the city's main lifelines, below 10%. Mashhad, Iran's second largest city, was being supplied by reservoirs at around 3% capacity, with one dam reportedly at 0. Iran was openly considering moving its capital, after years of internal proposals, to the southern coastal region of Makran, and the desert kept advancing. Now zoom back out to the Gulf as a whole, and the trap becomes obvious. The fossil water beneath the desert was largely gone. The rivers feeding the inland half of the Middle East are at historic lows. The Persian Gulf itself The very sea that these countries rely on for desalination is getting hotter and saltier every year, partly because of climate change and partly because of the brine that desalination plants pump back into it. The Arab Center in Washington, citing recent research, has noted that Gulf waters are now believed to be roughly 25% saltier than typical seawater, which forces desalination plants to use more energy to extract each new cubic meter of fresh water. The system that was supposed to free the Gulf from nature has now locked it into an even tighter dependency. Take away the cheap energy, and desalination becomes unaffordable. Let the brine push salinity higher, and desalination becomes harder. Let the climate keep warming, and demand for water rises just as the Gulf's ability to provide it starts to break. And then, in early 2026, came the warning that turned theory into reality. When the war between Iran on one side and the United States and Israel on the other spilled across the Gulf in late February and early March of 2026, the conflict almost immediately reached the one piece of infrastructure no one had wanted to discuss. On March 7th of 2026, Iran's foreign minister accused the United States of striking a freshwater desalination plant on Qashem Island, cutting off supply to around 30 villages. The very next day, Bahrain reported that an Iranian drone had damaged one of its own desalination plants. Kuwait and the UAE soon reported similar damage. The Atlantic Council and the Bulletin of the Atomic Scientists both warned, in pieces published in March and April of 2026, that the unspoken taboo against attacking water infrastructure had finally cracked. And the world suddenly remembered what hydrologists had been saying for decades. These countries aren't invincible. Their entire population can be put under existential pressure with a few drone strikes on the right buildings. Bahrain alone, with around 1.6 million people and over 100 desalination plants supplying more than 90% of its drinking water, is one of the most exposed countries on Earth. A handful of successful strikes could create a humanitarian crisis within hours. Saudi Arabia and the UAE have built up storage and redundancy. Bahrain, Kuwait, and Qatar are far more vulnerable. Take a step back, and the entire trap comes into focus. These nations have, in less than a century, used up most of their fossil aquifers, killed off ancient rivers and marshlands that they once shared with their neighbors. They made themselves dependent on energy-hungry desalination plants on a sea that's rising, warming, and becoming saltier, and exposed those plants to military and political risks that did not even exist a generation ago. So what was the miracle in the end? It wasn't the megacities, it wasn't the indoor ski slopes, not the wheat fields blooming in the desert. The real story was something much darker. These kingdoms didn't beat nature, they simply borrowed from it. They borrowed from rivers that were thousands of years old. They borrowed from aquifers that were tens of thousands of years old. They borrowed from a climate that, for a brief geological moment, was forgiving enough to let them cheat. And they spent it all on glass towers, golf courses, mega events, and dreams of becoming the next great global power. Now the lender has shown up, and the lender doesn't take meetings. The lender can't negotiate. The lender doesn't care how many billions of dollars are sitting in sovereign wealth funds. The desert is the desert. The sea is the sea. The atmosphere is the atmosphere. None of them have any obligation to keep playing along with the story written in marketing brochures. The miracle was real, for a moment. But miracles built on disappearing water don't last forever. And the question now is whether the bill will come due in the Gulf. The bill is already arriving. Tehran is rationing water. Iraq is begging Turkey for releases from upstream dams. Bahrain is patching drone holes in its desalination plants. Saudi Arabia has quietly killed its wheat program. Abu Dhabi is racing to bury up to 90 days of emergency water beneath the sand. The real question is, when the next great Middle Eastern crisis hits, will it be about oil, like every Western government's been preparing for half a century? Or will it be about something far older, far simpler, and far less negotiable than any commodity on Earth? Will it be about water? Well, tell us in the comments. Do you think that the Gulf can engineer its way out of this, or are we watching the slow-motion end of an entire civilization? And if you want to keep getting these breakdowns from us, hit subscribe. There's a lot more coming, and almost none of it is going to be reassuring.
For years, most people assumed China's moon program was mostly symbolic. A few rover missions, some flags. A prestige project meant to show the world that China could reach space too. But in 2024, something changed. Quietly, piece by piece, the curtain started lifting. On June 25, 2024, China brought back 1,935.3 grams of rock and soil from the far side of the moon. The first time in human history anyone had ever returned material from that side at all. The samples came from the South Pole Aitken Basin, one of the oldest and deepest impact structures in the entire solar system. Then came the renderings. For the first time, China and Russia publicly revealed detailed plans for something called the International Lunar Research Station, a permanent robotic and eventually human-supported base near the moon's south pole. Chinese scientists began exposing experimental lunar bricks outside the Tiangong space station, testing whether materials made from simulated moon soil could survive radiation, vacuum, and brutal temperature swings in space. Then came the power plan. In May 2025, Roscosmos and the China National Space Administration signed an agreement to study placing a nuclear reactor on the moon between 2033 and 2035 to power the future lunar base through the freezing 14-day lunar night. The missions aim directly at the darkest places on the moon, not the bright flat regions astronauts visited during Apollo, but craters near the lunar south pole that sunlight has not touched for billions of years. Craters cold enough to preserve frozen water ice from ancient comets and asteroids, water that could become oxygen, rocket fuel, and the foundation of a permanent off-world economy. For the first time, we are no longer guessing what China is building on the moon. The blueprint is finally visible. And if this works, the moon stops being a destination and becomes the first industrial outpost beyond Earth. Most countries that go to the moon focus on the landing. China focused on the system behind the landing. That difference changes everything. Back in the early 2000s, Chinese planners laid out a long-term lunar roadmap that stretched across decades. The goal was never a single dramatic mission. It was to slowly assemble every capability needed for permanent operations beyond Earth. First came Chang'e 1 in 2007. No landing, no astronauts, just mapping. The spacecraft orbited the moon for more than a year, building detailed topographic maps of the lunar surface and collecting the kind of geological data engineers would later use to plan future missions. Then came Chang'e 2 in 2010. Sharper imaging, better landing site analysis, higher resolution terrain models. Scientists could now identify dangerous slopes, unstable soil, and safer touchdown zones with far greater precision. Next, Chang'e 3 in 2013. China became the first country since the 1970s to soft land on the moon. The U-2 rover rolled across the surface, collecting geological data that immediately suggested parts of the moon were far more chemically complex than previously believed. But the real turning point came in 2019. Chang'e 4 landed on the far side of the moon, something many experts had considered nearly impossible because direct communication with Earth is blocked there. China solved the problem by placing a relay satellite called Queqiao in a carefully positioned orbit where it could simultaneously see both Earth and the far side of the moon. Next, Chang'e 5 and Chang'e 6. Sample return missions. Not just landing anymore, not just driving around anymore. Now, China was extracting material from the lunar surface, launching it back into orbit, docking autonomously above the moon, and bringing it all the way home to Earth. And the next missions go even further. Chang'e 7 is designed to hunt for water ice inside permanently shadowed craters.
With CGM Graybox, you could use stable diffusion to texture any model.
Terrain, wheeled
Frame your
rovers
shot in the
cannot
projection
survive.
camera and then hit
Chang'e
generate.
8 is designed
Here
to
we
test
have batch
in-situ
count
resource
set to 4,
utilization,
so we get
using
4
lunar
options
soil itself
generated
to
off of our
manufacture
mesh.
bricks,
Let's
structures,
pick this
and
one.
possibly future
Projection
habitats.
works on multiple meshes
Every
in the
mission was
scene.
teaching China how
On
to
second
survive
thought,
on the moon.
let's generate a couple
It was
more.
less like a sprint and more like assembling a giant machine one
Okay,
piece at a
this one
time.
looks pretty good.
Because the
Let's
final
set it
objective
as our
was never
projection.
simply visiting the moon.
And let's bake the
It was
projection
building
as a
infrastructure
texture
there
on
that stays.
all of the meshes. As you can see, a lot of detail is being lost. So let's reframe the shot
For
and start
decades,
bringing back
humanity
those
believed it
details.
already
We
understood
need to
the moon.
readjust our depth sliders for
After
this
all,
new camera
NASA's
position.
Apollo
And
astronauts
let's
had
adjust the
walked on the
prompt a little
surface,
bit to make
brought
sure we're
back
getting the
hundreds of
skull.
kilograms of
And now
rock,
generate.
and scientists had
Now we
spent
have
half a
4 more
century
options
studying
to
those
choose from.
samples in
Let's go with
laboratories
this one.
around the world.
And bake the
Textbooks
projection.
were written, geological models were built, an entire scientific story about the moon took shape. Then China landed on the far side. On June 1st, 2024, Chang'e 6 touched down inside the South Pole Aitken Basin, a colossal crater more than 2,500 kilometers wide and believed to expose material from deep inside the lunar interior. Over the next few days, the spacecraft drilled and scooped 1,935.3 grams of lunar soil and rock before launching the sample container back into lunar orbit, docking with a waiting spacecraft, and eventually returning the material safely to Earth on June 25, 2024. The mission even left behind a strange signature that spread rapidly online in China. A sampling mark shaped like the Chinese character Zhong, meaning middle or China. But the real shock came after scientists opened the samples. The rocks showed evidence of volcanic activity on the moon far more recently than many models predicted. One science paper published in late 2024 dated some of the far side basalt to around 2.83 billion years old, suggesting the moon stayed volcanically active much longer than previously believed. Another study suggested the lunar magnetic field may have strengthened again around the same period. Another found the far side mantle appears dramatically drier than the near side, implying the moon may be far more chemically asymmetric than scientists realized. In other words, the moon was not the simple, geologically dead world many people imagined. It was more complicated, more active, more valuable. And suddenly these missions no longer looked like symbolic exploration. They looked like prospecting missions. When most people imagine the moon, they picture a dead world. Gray dust, empty craters, a place astronauts visited once and left behind. But the most important part of the moon may actually be the one place sunlight almost never reaches, the lunar South Pole. And what makes that region valuable has nothing to do with scenery. It has to do with darkness. The moon barely tilts on its axis. Because of that, sunlight hits the polar regions at an extremely shallow angle, almost sideways across the surface. Some crater walls near the South Pole are so deep that sunlight never reaches the bottom at all. Not for a season, not for a century. In some places, not for billions of years. These are called permanently shadowed regions, and temperatures inside them can fall below minus 170 degrees Celsius, colder than the daytime surface of Pluto. For decades, scientists suspected those frozen craters were trapping something extraordinary. Water. Over billions of years, comets and water-rich asteroids slammed into the moon. Most of that water was destroyed by sunlight or escaped into space. But inside those permanently dark craters, the cold became a natural deep freezer. Molecules that entered rarely escaped. The result may be enormous reserves of ancient ice. Current estimates vary widely, but scientific models suggest the moon's polar regions could contain anywhere from hundreds of billions to potentially trillions of kilograms of water ice. And suddenly, the moon stops looking empty. Because water in space is not just water. Water is oxygen. Water is hydrogen. Water is breathable air. And hydrogen and oxygen together form one of the most powerful rocket fuels humanity has ever used. That changes the entire equation. Launching cargo from Earth is brutally expensive because Earth's gravity is enormous. Every kilogram sent into deep space has to fight its way out of the strongest gravity humans can currently launch from. But the moon's gravity is only about 1/6 of Earth's. If fuel can be produced directly on the lunar surface, spacecraft heading toward Mars, asteroids, or deep space missions could refuel there instead of carrying everything from Earth. The moon becomes a gas station, a supply depot, a launch platform for the rest of the solar system, and that is why the South Pole matters so much. Finding water on the moon sounds simple. Just send a rover down into a crater and start digging. Except those craters are among the harshest environments anywhere in the solar system. No sunlight, no natural heat. Temperatures cold enough to freeze most electronics solid, jagged terrain untouched for billions of years, and almost no margin for failure. A normal solar-powered rover would struggle to survive there for long. So, China designed something different. Chang'e 7. Currently targeted for launch around 2026, it is one of the most ambitious robotic lunar missions China has ever attempted. The mission is not just one spacecraft. It is an entire coordinated exploration system. An orbiter, a lander, a rover, and something no country has ever operated on another world before. A hopping probe. The orbiter will circle above the South Pole, mapping terrain and relaying communications back to Earth. The lander will touch down near the Shackleton crater region. A rover will move across the illuminated surface, searching for scientifically valuable targets. But the real star of the mission is the small jumping robot. Instead of relying on wheels, the probe is designed to leap directly into permanently shadowed craters that ordinary rovers cannot safely enter. It carries an instrument called LUWA, the Lunar Soil Water Molecule Analyzer. Its job is simple in theory and extraordinarily difficult in practice. Find usable water ice. The probe is designed for repeated hops of around 10 kilometers at a time, descending into craters where sunlight has not touched the surface for over 1 billion years. Think about what that really means. Humanity has explored deserts, jungles, ocean trenches, Antarctica, even the deep vacuum of space. But these craters are something stranger. Places that have remained frozen and untouched since before complex life even existed on Earth, and China built a robot designed to leap into them. Finding water is only the beginning. The harder problem is construction. Because shipping building materials from Earth to the Moon at scale is almost absurdly expensive. Every habitat wall, every landing pad, every radiation shield, every road, every kilogram has to survive launch, cross nearly 400,000 kilometers of space, land safely, and keep functioning in one of the most hostile environments humans have ever encountered. Long-term, that model does not work. So China is attempting something far more ambitious. Instead of bringing construction materials to the Moon, it wants to manufacture them there. That is the purpose of Chang'e 8, currently planned for around 2028 to 2029. This mission marks a major transition in China's lunar strategy. Exploration is giving way to infrastructure. At the center of Chang'e 8 is a series of ISRU experiments, in situ resource utilization, which basically means using local lunar material instead of transporting everything from Earth. One of the most important systems is a solar concentrator furnace. Using focused sunlight, the device is designed to heat lunar soil to roughly 1,400 to 1,500 degrees Celsius, hot enough to melt regolith and turn it into solid construction material. In simple terms, China wants to bake bricks out of moon dust. The system is expected to 3D print structures layer by layer at roughly 40 cubic centimeters per hour. That may sound slow, but on the Moon, even small autonomous construction capability changes everything. Landing pads could reduce dangerous dust clouds during spacecraft touchdowns. Protective walls could shield astronauts from radiation and micrometeorites. Roads could stabilize rover traffic across loose terrain. Future habitats could eventually be printed directly onto the lunar surface itself. And China is already testing whether these materials can survive space. In November 2024, experimental lunar brick samples were delivered aboard the Tianzhou 8 cargo spacecraft and mounted outside the Tiangong space station for long-term exposure testing against radiation, vacuum, and extreme temperature swings. At the same time, Chinese researchers are developing autonomous robotic construction systems, sometimes referred to as lunar spider robots, designed to assemble structures with minimal human supervision. This is the real shift happening right now. The Moon is no longer being treated as a place humans briefly visit. It is being treated as a place where machines can begin building permanent systems before humans even arrive. And once robots can manufacture infrastructure using local resources, the economics of space change completely.